Hi everyone, welcome to Math Magic. Have fun and learn mathematics in a magical way. For this video, we will talk about the real numbers system. In this lesson, we will know and determine the following kinds of numbers and its relationships. First, the real numbers. Second, rational numbers. Third, irrational numbers. Fourth, integers. Fifth, non-integers. Fractions, whole numbers, and natural numbers. Let's now begin. Let's begin our lesson with a definition of real numbers. What are real numbers? By definition, any number that can be found in the real world is a real number. We find numbers everywhere around us, right? For instance, when you count objects, you'll start with 1, 1, 2, 3, and so on. In that case, you use the set of natural numbers, or it is also known as the counting numbers. When representing the fractions, we use rational numbers. We use also irrational numbers in calculating the square root of a number, and integers for measuring temperature. These terms here, natural numbers, rational numbers, irrational numbers, integers, these are numbers which make a collection of real numbers. To better understand about real numbers, if we want to visualize it, we will consider this Venn diagram of the real number system. Let's try to understand this one. Suppose this rectangle here represents the set of real numbers, meaning everything inside this rectangle are elements or members of the set of real numbers. The set of real numbers, for example, here we have two subsets, the rational numbers and the set of irrational numbers. As you can recall, based on our previous video tutorial, we defined there the set of rational numbers. The set of rational numbers are numbers that can be expressed in a form of a fraction, a over b, where your a is your numerator and b is your denominator, and your denominator should not be equal to 0. So any number that can be expressed in a fraction form are known as rational numbers. And any number that cannot be expressed in a fraction form, a over b, where b is not equal to 0, are known as irrational numbers. So observe that these rational numbers and irrational numbers are under or inside the set of real numbers. So meaning you can classify rational numbers and irrational numbers as part or a subset of real numbers. The set of rational numbers also, we have two subsets, the set of integers and the set of non-integers. Okay, when we say non-integers, as what you can recall based on our previous discussion, when we say integers, it composed of, at the center we have 0, and going to the left, negative, and going to the right, it's positive. So we have here the subsets, the negative integers, starting -1, then -2, -3, up to negative infinity. When I say negative infinity, infinity means endless. So numbers, the negative numbers, has no n. So meaning the negative numbers, it starts with -1 and then -2, -3 up to negative infinity, meaning it's endless. And the set of whole numbers. When we say whole numbers, it involves the positive numbers and 0. So the positive numbers are numbers to the right of 0. So it begins with 1, 2, 3 up to positive infinity. So meaning we say positive infinity, it's still endless. And also it involves or include 0. So this comprises the set of integers, the negative integers, the positive integers, and 0. And the whole numbers, as what you can notice, it includes positive numbers and 0. Okay, then how about non-integers? The non-integers includes the decimals and the fractions. So meaning this set of decimals and fractions belongs to the set of non-integers. So not all decimals not all decimals are considered as non-integers. We should take note this one, that decimals which are terminating and decimals which are repeating and non-terminating are only classified as non-integers. When we say terminating decimals, those decimal numbers that terminates or stops. While repeating and non-terminating decimals, you say repeating, the decimal part there, the numbers there are being repeated, and it will not terminate, or there is no end. While the set of irrational numbers also, it includes the decimals, but if we are going to compare, for the non-integers, it's repeating. For the irrational numbers, it's non-repeating and non-terminating decimals. For example, if we'll say 1.1, 2, 3, 4, 5, 6, 7, 8, and so on. So the decimal part there is not being repeated, but it does not terminate. So how about for this one? Repeating decimals and non-terminating decimals. For example, 0.333 repeating. So it is classified as repeating and non-terminating decimals because the decimal part there is being repeated and it does not terminate. So if we're going to interpret this Venn diagram, everything inside this rectangle are real numbers. So if I'll ask you, are negative numbers can be classified as real numbers? The answer is yes, because it's it's a family of real number system. So everything inside this rectangle are members of real numbers. So the negative numbers, the whole numbers are members of integers. And the integers and non-integers are members of rational numbers. And the non-repeating and non-terminating decimals are members of irrational numbers. And rational numbers and rational numbers are members of real numbers. Now, to better understand the relationship of the different kinds of numbers, here is now the hierarchy chart of the set of real numbers. Alright, so at the topmost, this is the real number system. So this is now the set of real numbers, and it has two subsets, the set of rational numbers and the set of irrational numbers. So the set of rational numbers, as defined a while ago, Rational numbers are any numbers which can be expressed in a fraction form, a over b, where b is not equal to 0. For example, 1/2. So in this fraction, your numerator or your a is equal to 1 and your denominator is equal to 2. So this is now considered as a rational number. How about 0.333 repeating? This is still an example of a rational number because this can be expressed in a fraction form. And the equivalent fraction form of this is 1 over 3. So any number that can be expressed in a fraction form is known as a rational number. Another subset of a real number is the irrational number. What is the difference between a rational number and an irrational number? Let us compare this decimal here, 0.333 repeating. This is known as repeating decimal as well as non-terminating. So if we compare it to the irrational number, for example, 1.23768 and so on, this is considered as a non-repeating because the decimal part here is not being repeated. And it is non-terminating because of these 3 dots here. This kind of decimal cannot be expressed in a fraction form. So any number which cannot be expressed in a fraction form is known as or is classified as or can be classified as an irrational number. For example, if we'll have the value of square root of 2. 2 is not a perfect square. So there is no exact number that when you multiply it to itself is equal to 2. So its answer is between 1 and 2. So there is no exact number. It is the answer for square root of 2 is non-terminating and non-repeating decimal. So that's why it is classified as an irrational number. And this rational number here, we'll go back to this rational number. This rational number is divided further into 2. We have the set of integers and the set of non-integers. When we say integers, these numbers the set of integers comprises the positive numbers, 0, and the negative numbers. So for example, we have here -1, -2, and so on to the negative infinity, and we have 0 at the center, and going to the right we have positive numbers, +1, +2, and to positive infinity. So these numbers, these integers, are classified under the rational numbers. How about the non-integers? What's the difference between the integers and non-integers? Non-integers are decimal numbers and fractions. So, for example, 1/2, this is classified as under non-integers. And 0.45, this is an example of a terminating decimal. And another 0.333 repeating. This is an example of a repeating and non-terminating decimal. So these integers and non-integers, these are classified under rational numbers. And rational numbers are classified under the real number system. Let's focus here on the integers. So the integers, or the set of integers, are classified into 2. We can divide it into 2, the set of negative numbers or negative integers and the set of whole numbers. So negative numbers, we have -1, -2, up to negative infinity. And the set of whole numbers are the set of counting numbers including 0. So it starts with 0, 1, 2, and so on. And furthermore, these whole numbers or set of whole numbers is divided into two, 0 and the natural numbers. And a set of natural numbers starts with 1. So 1, 2, 3, and so on. So the set of natural numbers or counting numbers should start with 1 up to positive infinity. And for the non-integers, we have here the fractions. And then we have the terminating decimals like 0.45 and the repeating and non-terminating decimals. So if you analyze this hierarchy chart of the set of real numbers, it means that 0 can be classified under whole numbers. Natural numbers can be classified under whole numbers. And then whole numbers and negative numbers, if we're going to combine it, or we'll get the union of these two sets, we can form integers or the set of integers. And if we'll analyze in this part, terminating decimals, repeating and non-terminating decimals, fractions are all classified under the set of non-integers. And the set of integers and non-integers are classified under the set of rational numbers. And the set of rational numbers and irrational numbers are under the real number system. Let's try this. Determine the subset of real numbers to which each number belongs. Negative 86. Is it a whole number? No, it's not a whole number, because when we say whole numbers, it starts with 0, then 1, 2, 3, 4 up to positive infinity. So it does not include negative numbers. How about integer? Yes, it's a negative integer. Is it a rational number? Yes, it's a rational number, because all integers are under the rational or the set of rational numbers. Of course, if it's rational, then it is not an irrational number. How about 34.74? Is it a whole number? No, it's not a whole number, because it has a decimal value here, 0.74. Is it an integer? No. Decimals are non-integers or classified under non-integers. Is it rational? Yes, of course, it's a rational number since it's a terminating decimal. It terminates at hundreds place. Of course, it's not an irrational number. How about 4/7? Is it a number? No, it is a fraction. Is it an integer? No, because these fractions are classified under non-integers. Is it rational? Yes, it's a rational number, because when we talk about rational numbers can be expressed in the form of a fraction a/b, where your b is not equal to 0. And of course, it is not an irrational number. How about square root of 64? Square root of 64, let's focus on the radicand. The radicand 64 is a perfect square. Why? Because there is a number that when you multiply it to itself equals 64, and that is positive 8 and negative 8. Because when you multiply positive 8 to itself, 8 times 8 equals 64, right? And negative 8 times negative 8 is equal to 64. So we have here, if we consider its positive root, and it's a whole number. And it's an integer, of course. And it's a rational number because it's a perfect square. And of course, it's not an irrational number. How about square root of 11? Square root of 11, this radicand here, 11, is not a perfect square because there is no exact number that when you multiply it to itself is equal to 11. So meaning it's not a whole number, it's not an integer, it's not a rational number. So meaning it can be classified as an irrational number. If we'll approximate its value for square root of 11, that's between the square root of 9 and square root of 16. And square root of 9 is 3 and square root of 16 is 4, meaning it's in between 3 and 4. We're going to solve this one. It's approximately equal to 3.31662479 and so on. As what can you observe that number is a non-terminating and non-repeating decimal, so meaning it is classified under an irrational number. How about 0.4545 repeating? Of course, it's a decimal number, meaning it's not a whole number. It's not an integer because it's a decimal number. Yes, it's rational. Why? Because it is a repeating decimal. Non-terminating and repeating decimal. So it's rational. And of course, it is not an irrational number. How about negative 1.3678 and so on? This is an example of a non-terminating because this three dots, it means that it is endless. And the numbers here are not being repeated, so meaning it is non-repeating, non-terminating decimal, meaning it's under the irrational number. Thank you everyone, and God bless.